Question number 4. This question is from work power and energy. Work power and energy. An athlete of mass 84 kg is running along the straight road. An athlete of mass 84 kg is running along a straight road. Part A of this question is initially the road is horizontal. Initially, the road is horizontal and he runs at a constant speed of 3 meter per second. Constant speed of 3 meter per second means constant speed means acceleration will be 0. Acceleration will be 0 for constant speed. The athlete produces a constant power of 60 watt. What is the unit of power? Constant power of 60 watt. Find the resistive force which acts on the athlete. First, we make a diagram. This is the data of the question that mass of the athlete is represented by M, 84 kg, and power is 60 watt, and speed is 3 meter, constant speed is 3 meter per second. A constant speed means that acceleration is 0. Since the speed is constant, acceleration will be 0. This is a very simple diagram. This is a horizontal road. We are making a horizontal road. And let this is a athlete running to this side. Driving force, let driving force is F, and the resistive force which we have to find, resistive force opposes the motion, so its direction will be opposite to the driving force. We were representing a resistive force by a small letter F, and the driving force we are representing by the capital F. So uh, we know that since the power is 60 watt, we will convert it into driving force. We are using this relation. We know that power, this is formula for power. Power is equal to F into V. From here, F will be P over V. So, driving force will be 60 over 3, that is 20 meter per second. This is the driving force. 20 meter per second. Now we are using here Newton's second law of motion, which is F is equal to ma. Now this F will be the net force. Net force will be a driving force minus resistive force. So we will write that F driving force minus resistive force is equal to ma. Since acceleration is 0, so right side will be 0. Now, from here, F is driving force is 20. We have found, just putting here the value 20 minus F is equal to 0. From here, we can find the value of small f, that is resistive force. So, resistive force will be 20 Newton. Now, part B of this question is the athlete then runs up 150-meter section of road which is inclined at 0.8 degree to the horizontal. The speed of the athlete at the start of this section of road is 3 meter per second, and he now produces a constant driving force 24 Newton. The total resistive force which acts on the athlete along this section of road has constant magnitude 13. use an energy method to find the speed of the athlete at the end of 150-meter section of the road. So first of all, we will draw a simple sketch to understand this question. We mention all the data on this diagram. So first of all, know the section of the road athlete runs up 150-meter section of the road which is inclined 0.8 degree to the horizontal. We will make an inclined plane making an angle 0.8 degree with the horizontal. This will be the diagram. We sketch a simple diagram. This is a horizontal path, horizontal road, and now inclined plane motion along this track or making an angle 0.8 degree. Now this section is inclined plane is this section, then the length of this section is 150 meter. So we can represent here that this track is of 150 meter. At the start of the inclined plane, the speed is 3 meter per second. We are representing by u. U is suppose speed at this point. This point is a. Speed here is 3 meter per second. U is equal to 3 meter per second, and let this point is point B. Here speed we have to find. Now in this question, driving force is given, that is 24. Constant driving force is 24 Newton. We can write here that the data is driving force is for this part B 24 Newton, and the resistive force resistive force for which acts on the athlete along this section of road has constant magnitude 30 Newton. So we are representing this resistive force by small alphabet F, that is 13 Newton. Now we have to find, actually use an energy method to find the speed of the athlete at the end of 150-meter section of the road. 150-meter section of the road is this. From A to B is 150 meter. We have to find the speed of this athlete at point B. We will use energy method. Energy method. This is very important formula for energy method. I am writing here in the short form. Work done by driving force, WD, mean work done by driving force will be equal to work against friction plus change. This delta shows a change in mechanical energy. In this formula, mechanical energy means sum of kinetic energy and potential energy. Mechanical energy is a sum of potential energy plus kinetic energy. We will find the change by we will subtract the final mechanical energy. Change of mechanical energy means final mechanical energy minus initial mechanical energy. Work done by friction. Work against friction means F into small f into d. Work against, because we have represented the resistive force by small letter f. Work done by driving force. Now we will use this driving force. So work done by driving force will be capital F into D. So we will put here the values. So we have to find the potential energy. We need this height. We need this height of the athlete from A to B. This is the vertical distance. This is height. We have to find this. So we make this a little change in this, further making the diagram. This is the height represented by h. Now this triangle is a right angle triangle. Here we will use the trigonometric ratio to find this h. Now we are using sine theta perpendicular over hypotenuse equal to sine 0.8 degree. So we can easily find the height from here. So height will be can be found by the ratio h over 150 is equal to sine of 0.8 degree. From here h is equal to 150 into sine uh, 0.8 degree. We get h is equal to 2.094 meter. This is the height. Now putting the first we will find the mechanical energy uh, at point A and mechanical energy at point B. First we find mechanical energy at A and mechanical energy at B, because we need this change of mechanical energy in this work energy relation. This formula is also called the work energy relation. So first we will find the mechanical energy at A and B. Mechanical energy at A point will be mgh, potential energy plus kinetic energy. Potential energy mgh, kinetic energy 1 over 2 mv square. Putting the values, m we have given the value of uh, the mass of the athlete is 84. So mgh will be 0 at this point A, because no height. So potential energy at this level at point A will be 0, because there is no height. So in place of mgh we can put 0 plus kinetic energy 1 over 2. M is 84, v square, v is 3 meter per second at this point A, represented by u. So we are putting here the value of u3, with taking square this will become 3 square, and calculating this we get mechanical energy at this point A will be uh, 378 joule. This is mechanical energy at point A. Now in the same way we will find the mechanical energy at B. Mechanical energy at B at point B, this will be mgh plus potential energy plus kinetic energy Now putting the values, m is 84, g is 10, acceleration due to gravity, height just we have found, that is 2.094 plus 1 over 2 m v square, m is 84, v square we have to find. This will be cancel out, 2 into 84, that is 42. Cancel out, uh, and we will find the product of these three terms, and we get here uh, 1759 plus 42 v square. This is mechanical energy at B. Now we are using this formula, that is called work energy relation. Putting here the values. Let's say this is equation number 1. Now from equation number 1, putting the values, work done by driving force will be F into D. We are using this capital F, value of capital F, because this is driving force. F into D, that will be 24 into 150 is equal to work against friction, that is WF, small f into D. Small f is 13 into D is 150. 13 into 150 plus change in mechanical energy. Change in mechanical energy means change of change will be the final value of mechanical energy minus initial value of the mechanical energy. Since the athlete, the position of the athlete is moving up the plane, so this is the final position, this is the initial position. So final mechanical energy minus initial mechanical energy will be the change in mechanical energy. So final mechanical energy is this 1759 plus 42 v square. Initial mechanical energy is 378. So putting here the values, 1759 plus 42 v square minus 378. From here we can find the value of v. Now simplifying it, 3600 is equal to, this is 3600, and this will be 1950 plus 1759 plus 42 v square minus 378. After simplifying we get 42 v square is equal to 3600 minus 1950 minus 1759 plus 378. Now we will add up these terms. We get finally 42 v square is equal to 269. From here, v square is equal to 269 over 42. Taking the square root, we get 269 over 42 square root. Finally, the value of V will be 2.53 meter per second. This is the answer. 2.53 meter per second. This is the speed of the athlete at point B.